For today's project, we will combine electrical engineering with mechanical engineering to create a Trembler mover. This is a small robot that will move and dance on its own.
Now that we know what we're making, let's go over our materials. You should have a brown rectangular CCL box that looks just like this, and inside this box you'll have all your materials. I'm going to open it up. You should have one AA battery holder, two AA batteries, a 3-inch copper strip of tape, a 3-volt motor, two double-sided squares, a plastic bottle cap with a hole on the top, and two googly eyes. Now that we have all of our materials, let's get started with building.
First, we're going to secure the bottle cap onto the small pole on the motor by poking it through the hole which is already in the bottle cap. If you look at the motor, you should see that it has two flat sides, one with wires and one without. Place a square of double-sided tape on the flat side of the motor without the wires. Ensure that the tape does not interfere with the bottle cap being able to spin on the motor. Now use the other side of the double-sided tape to attach the motor to the top of the cardboard box. It's best to do this on one of the shorter ends of the box. Again, ensure that the box does not interfere with the bottle cap being able to spin. Next, we will attach the battery holder. Ensure that the battery holder is turned off and that there are no batteries inside. We won't add the batteries until the very end to ensure that we are staying safe. Place a double-sided square on the side of the battery holder without the on and off switch. Secure the battery holder to the top of the box using the other side of this double-sided square. We want to place the battery holder on the opposite end of the box as our motor, and we want to face the wires towards the motor to make them easier to connect. Once you have the wires connected with copper tape, we'll use a small piece of normal tape to tape the wires onto the box of the Trembler mover so that they do not interfere with our motor. You can now encourage your students to decorate the Trembler mover using the googly eyes, and once you are ready, you can remove the top of the battery pack, insert the two batteries, slide it back on to secure it, and we are now ready to test our Trembler mover. To test our Trembler mover, simply flip the switch on the battery pack into the on position. The bottle cap should start to spin, allowing the Trembler mover to move around on its own. If your Trembler mover is not working, there are some steps you can take to fix it. Also, make sure to switch the battery pack off before making any modifications. First, check if the batteries are inserted in the correct position, with the flat side of the battery touching the spring in the battery holder. Next, try pinching the copper tape connecting the wires, as this connection can sometimes be loose. You can also unravel the copper tape to ensure that the silver pieces of each wire are touching inside of the copper tape. Replacing the copper tape can also help if the motor still does not spin. If the bottle cap flies off, you can try securing it with tape or try poking a new hole into the bottle cap. This hole should be slightly off-center to create a vibration. We now have a working Trembler mover that can move on its own, but how does it work? In our Trembler mover, we created a circuit to allow the electricity to flow. You can think of the circuit as a racetrack where the electricity can only flow in one direction if the circuit is completed. From a simplified perspective, the electricity flows out of the battery pack through the wires and to the motor, causing the motor to spin. The electricity then flows out of the motor and back into the battery pack, completing the loop. This movement of electricity over a path is called a current. The spinning motor spins our bottle cap, which creates a vibration. This vibration causes the box to shake and move on its own. And now that you know how the Trembler mover works, there are some things you can think about with your students, such as, where does the energy come from to rotate the bottle cap? How can we make the cap spin faster? And why might we poke the hole off-center?